Hello, Todd again, your logic tutor. Continue with some problems in natural deduction using the rules of inference. This problem here, we're looking for a not R. So first thing we do is look through our premises to see where we might, in 1 through 4 our premises, see where we might find a not R. And we see a not R in line 4. And line 4 is a conditional. So what that means is the way that we can get a not R is by finding the antecedent. We need a P and a Z. Okay. We don't have a P and a Z anywhere. That was kind of messy. Gotta get it out of the way. So we need this P and this Z. We don't have it anywhere, but it is a conjunction, P and Z. So if we can get the P by itself and the Z by itself, we could put them together by conjunction, then we could get our not R. So let's think about getting the P and the Z separately, one at a time. Let's think about the P. Look at line 3. It says P and Q. Well, I can get a P out of that very simply by, let me make this bigger, by simplification from 3 by simplification. So now I have my P. So now what I need is a Z. And I notice there's a Z in line 2. Now look what we need to get the Z. That big antecedent, A or B or not J, and the only thing we have to work with is an A. Well, the thing to notice is that it's all ors in there, which means we can build that antecedent by using the A. Watch. A or B, that's from 1 by addition. We can add whatever we want. Okay, that's line 6. And remember, we're trying to get this antecedent in line 2, so we also need an or not J. So what we're going to do is we're going to take this A or B, and we're just going to add or not J. That's from 6 by addition. And now 7 is the antecedent to 2, so we can do a modus ponens and get Z from 2 and 7 modus ponens. So now we have the two parts, the P and the Z. Let's put them together. P and Z from 5 and 8, 5 and 8, and that's conjunction. So now look, 9 and 4. We can do a modus ponens and get not R. That was 4 and 9 modus ponens, and we're done. Okay, let's do another. Okay, this one here, let's see. P or not X and Q. Well, now notice that the main operator here is a conjunction, which means if we have P or not X and we have Q, if we get those separately, we can just conjoin them together. So let's think about those jobs separately. And besides, the Q is just waiting. So what we really need is the P or not X. There's a P and X on line 1, which we can turn into a P or X as follows. First, let's get rid of that X by simplification. So we get P from 1 by simplification. So we just drop that X, and we're going to add or not X from 3 by addition. So now look, we've got P or not X, and we have a Q on line 2. So all we have to do is put them together. P or not X and Q. That was lines 2 and 4, 2 and 4 by conjunction. Okay, another. All right. We have to prove this up here, not f if and only if g and h. Got three premises. This problem is very similar to the other one. I think that since this is a conjunction, we should go after both parts separately and then put them together by conjunction. So let's go after the not f if and only if g. I don't see that, but remember, when I don't see what I need, look for its opposite in an antecedent, which is right there in 1. Why do we look for that? Because if we have the opposite of the consequent, which would be a not q, we could do a modus tollens. And look what's down on line 3, a not q. So 1 and 3, we can do a modus tollens, and that gets us not f if and only if g. That's 1 and 3, modus tollens. Okay. So we've got part of the conjunction we need to make. Now we just need the h. And I can get an h from 2 if I have a not q, and I have a not q on line 3. So I'm just going to say h from 2 and 3, modus ponens. So now I have the two parts I needed from my conjunction, not f if and only if g and h. Those come from lines 4 and 5 by conjunction. I think we have time for one more problem. Prove g. 1, 2, 3 are the premises. So I'm looking around for a g, and I notice it's in line 1. It's in the second disjunct. So I need to get that second disjunct, and then I'll worry about how to get the g out of that conditional. So in order to get the second disjunct of an or, I need to find the opposite of the first disjunct. I need an L or M. I have an L down on line 3, so what I'm going to do is I'm going to add or M by addition. So now I can do a disjunctive syllogism with 1 and 4. What that gets me is A, then G. That was 1 and 4. Disjunctive syllogism. I wanted a G, and all I need is an A. It says if A, then G. There's an A in line 2, so I can say G from 2 and 5, modus ponens. Simple.